In this video, we will discuss regarding the conversion of ejector assembly of mold base into the ejector assembly of mold. Now you are seeing that this is the ejector assembly of the mold base. This is the ejector assembly of the mold base, which you have already seen in a separate video, and the ejector assembly has been discussed in great detail. So I will not discuss again, and I will only discuss regarding the conversion. So now you are seeing that here there is nothing, no holes, no ejector pin, no screw puller pin. So the retaining plate will be machined and the 6 counter bored holes will be machined for ejector pins, and 1 counter bored hole will be machined for screw puller pin. So now I will remove it. Now you are seeing this is the retaining plate of the mold. Retaining plate of the mold. Now you can see there are total 7 holes, and these are the 1, 2, 3. These 3 holes are for the ejector pin for 1 core insert, and these 3, 1, 2, 3 ejector pin holes, they are for the second core insert. They are through holes, through counter bored holes, through counter bored holes. In the center there is a counter bored hole for the screw puller pin. I will turn it now and you will see that they are counter bored holes. I think you can now see that they are counter bored holes. So I will insert the ejector pin. This is the ejector pin which you have already seen in other videos. This is a simple pin with the head. This is the head. So I have inserted 3, then 3 more. And this is the screw puller pin. There is a profile like a undercut. This is undercut profile at the here. You can see here this is undercut profile. So it will come here like this. So now I will turn it. Now you can see that the ejector pins have been inserted, and these ejector pins will eject the molding. So this retaining plate will come onto this ejector plate. This is the ejector plate in which this ejector guide bush are fitted, and here there is no machining, some marks are there, so drill marks. So this retaining plate will come over the ejector plate like this, and then the screws will be tightened. So now you can see that the ejector assembly of the mold base is converted into the ejector assembly of the mold. So this is the process of converting, and these ejector pins, they are floating pins. They are loose. They are not tight. They are loose. Similarly, this also will loose. So there is a clearance of 0.4 millimeter per side between the ejector pin and the hole counterboard hole of the which is made for the ejector pin, 0.4 millimeter per side. The ejector pins float because it will pass through the core backplate, it will pass through the core plate, it will be guided in the core insert. Now there could be manufacturing defects. The hole which is done in the core backplate, in the core plate, and in the core insert may not be exactly straight. It could be slight taper. So to take up the adjustment, these ejector pins are floating so that they can float in X direction, Y direction, and in Z direction. Means there is a clearance, as I said, 0.4 millimeter per side, and the head of the ejector pin also is less than the depth of the counterboard, around 0.05 millimeter. Then only it can float. Otherwise it will jam. So the head thickness of the ejector pin is less by around 0.05 millimeter than the depth of the counterbore. So that is how it will float. It will float. It will float. It is loose. That is, it is loose. It can take up some adjustment. So this is all about conversion of the ejector assembly of the mold base to the ejector assembly of the mold. Thank you.